Assalamualaikum. My name is Muhammad Hanif Abdul Subahi. We from Group 6 will present about our project. Okay, first, for the introduction, in communication system, noise is an error or undesired random disturbance of a useful information signal. Noise is, however, typically distinguished from interference. For example, in the signal to noise ratio (SNR), signal to interference ratio (SIR), and signal to noise plus interference ratio (SNIR) measure. In terms of definition, signal to noise power ratio often written SN or SNR is the ratio of the signal power level to the noise power, or to be more specifically, it is a ratio between the desired information or the power of a signal and the undesired signal or the power of the background noise. SNR is the ratio of signal power to the noise power, and its unit of expression is typically expressed as a single numeric value in decibel dB. The higher the ratio, the better the signal quality. Okay, in this group project, our group need to propose a solution to produce the highest signal to noise ratio (SNR) output of the communication system from the consistently 5 watt retrieved signal and bandwidth of 400 MHz. So it requires us to increase our understanding in signal to noise ratio (SNR) in doing this project. Higher number indicate a better specificate since there is more available data, the signal, than undesired data, the noise. So our group have choose increase the TR, time to repeat, increase the NEX, next, number of excitation, and increase the FOV, field of view, as the solution that can enhance the output SNR. Next is for the understanding of this project problem. So the fact is, from this project is the communication system from consistently 5 watt receiving signal and bandwidth of 500 MHz. All the amplifier devices are portable, can be relocated inside chamber. All chambers are non-portable. The idea is finding which position of amplifier that help improve the performance of SNR. Find information about relationship between noise, temperature, and SNR. Find the method that causes lesser noise while give best output SNR. The learning outcome from this project is high temperature reduce SNR performance. The higher the SNR, the good performance it could deliver. The action is make the calculation by using Fritz's formula to calculate the total noise factor of several cascade amplifiers. Come up with solution to overcome the problem to produce the highest signal to noise ratio. So, as the guideline for the study, fact will gather via problem-based learning question. The scope of the research can be complete within the state range with the aid of the gathering information in the pillar table. As a result, information on the link between noise, temperature, and SNR must be shared among group members. As the consequence, additional option for the end output may be chosen. According to the data accurate, SNR performance suffer as a result of the high temperature, and a solution with high SNR necessitates the use of mathematical calculation. The ideal amplifier layout may be determined using quiz formula and the impact of output SNR. That's all for me, and I will pass to the next presenter. Thank you.
Hello, my name is Muhammad Arif Azman. My matric number is CE190131. I'm going to explain about brainstorm process for the entire task. Before that, I need to explain about brainstorm process, which is a method of generating ideas and sharing knowledge to solve a particular problem, in which participants are encouraged to think without interruption. Participants also share their ideas as soon as they come to mind. With that, there's a certain, we create a limitation for brainstorming process by creating flowchart to maximize. Okay, the purpose of the flowchart is to outline the process main components while also providing a larger picture of the brainstorming process. When monitoring a physical process, it is used to record activities as they occur in order to provide an accurate description of the activity. It is a method for efficiency planning that is used when studying the phase in a process to assist, discover and remove waste. As for this task, for the first block, we learn the problems for this particular task, and then we gathering information, and then we start to take care of the arrangement of the amplifier. Well, as there are 3 amplifiers with 3 unmovable chamber. To find the best arrangement, we find noise factor and temperature for each chamber, and then we find power gain for each amplifier for each arrangement. As this is a repetition of process to decide which arrangement of amplifier give better output SNR by finding the SNR input first and make a total noise factor. With that, we can find the SNR output. With that, we get information on method to enhance the output SNR. There's 3 given information, and we simply decide the final decision within among us to which method of enhance the output SNR is the better. That's all from me.
Hi and Assalamualaikum. Now we will discuss about the solution for question 1. So for question 1, the practicable solution is by the arrangement of the amplifier placed inside the chambers. So we have provide the calculation as a proof for these solutions. So first, from the question, we got the signal input, we got the bandwidth, and also we got the temperature inputs. Next is for the specification for components, where we got amplifier and chamber. So for the amplifier, we got the power gains. For the chamber, we got the noise factor F and also the temperature. So all of these parameters we will be using for the calculation process. So now we will calculate for the SNR outputs. Before that, like I said before, the solution is by the arrangement of the amplifier. So the possible arrangement we got for amplifier is 6 arrangements, which we got case 1 up until case 6. So back into the calculation for SNR input. So first we will need to find the environmental temperature, TE. So here are the formula for the TE. So the A here is for the power gain for amplifier in first row, while AB is for the power gain for amplifier in second row. So with this, each cases will give a different value of TE. It will affect the noise input and also the SNR input for each cases. So here are the value for the each of cases SNR input. So this value will affect the SNR outputs in the below calculations. So now we will move into the calculation for SNR outputs. Same with the above, we have also got 6 cases. So in order to find SNR output, first we will need to find the total noise factor, FT. So here are the value for the FT. So now we have got both value for F and SNR input, which are at above. So now we get to calculate for the SNR output value. So here are the SNR output value for each cases in both unitless and dB parameter. So from the calculation above, we know that to produce the higher signal to noise ratio, which are SNR outputs, is by placing the amplifier from highest gain to the lowest gain. So from the calculation, we know that the arrangement of amplifier 3, amplifier 2, and amplifier 1, which are the case 6, give the highest possible value of SNR output, which is 117.67 dB. So that's all for question 1. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Fikri Prince Bawi. Number matrix is AE190041. I and Fazali will explain about this, represent about the solution for question 2. Okay. For the beginning, we need to know what is SNR. SNR is short term for signal to noise ratio. The signal to noise ratio compares the strength of the signal to the strength of the noise. Decibels are the most common unit of measurement. Highest number indicate a better specification since there is more valuable data than undecided data. So, how we can enhance the output SNR? Here are some solutions, which is increase the TR, time to repeat, increase the next number of excitation, and increase the FOV, field of view. What is increase the TR, time to repeat? It is as the longitudinal magnetization approaches its maximum and produces high signal intensities. Increasing the TR will enhance the SNR. However, increasing the TR beyond a certain point reduces the T1 impact. There is a picture they show the value of TR, and when the TR is higher, the SNR is always will high too. Okay, the signal to noise ratio SNR is a measurement of how well a magnetic resonance imaging MRI equipment works. An MRI picture is made up of a mix of MRI signals and unavoidable background noise rather than just MRI signals. There's the formula that's given is that MRI image equal to signals plus noise.
Hello and Assalamualaikum. I am Muhammad Nufazari bin Adnan and my matrix number is AA190060. So I will continue the explanation to increase the SNR output. So this is one of the factors that will increase the number of SNR, which is increased number of excitation, also called next. So the number of excitation or signal average can be denoted the number of times a signal from a given slice case space is measured, and the SNR, which is proportional to the square root of the next. It will improve as the next increase, but the scan time also increase linearly as the next increase. For example, when the next is double, the SNR increase by 140% and the scan time is also double. So by using next, we can enhance the quality of the MRI scan or any other SNR application. So for the next one is the FOV. We can increase the FOV to increase the SNR output. So FOV is defined by the size of 2 or 3 dimensional spatial encoding area of the MRI image. The pixel size is also determined by FOV, and the pixel size will increase when FOV is increased. So increasing the number of signal received by individual pixel, and large pixel will receive more signal, resulting in high signal to noise picture. So that means it means a bigger picture or a more clear picture. So at the most right, we can see that it is high SNR, but it is too high, so it becomes a little blurry. So at the middle is the good SNR, so we can see the picture clearly. And the last one is low SNR, which is still blurry as the first SNR, which is high SNR. So for the best solution, we choose the number of excitation so to control to increase the output of SNR, because the first one is we only need to repeat the process to gather the data and obtain a more exact image or signal. And the second one is in high resolution imaging with a small FOV. Next can be employed to boost SNR. And the third one, motion and pulsation artifacts can be reduced by using several signal excitation. And the last one, the sole negativity of raising next is that acquisition time will significantly rise. So that's all for me. Thank you.